By the end of today's lesson, I'm going to expect for you to be able to do 3 things. Compare unlike fractions using 3 methods. The first method is by using a visual model. The second method is by creating common denominators. And the third method, which is a little new for us, it's going to be by creating benchmark fractions, okay? What exactly does a fraction show, Amaya? What does a fraction show?
A fraction shows parts.
A fraction shows parts. Parts of a what, class? Parts of a whole. Now, is this a topic that we're just learning in our book and we're never going to use it again?
No.
How do we use fractions in our everyday lives?
When you're like a person that cooks.
How would a person who cooks need fractions?
Like measurements to cook, like you gotta make milk.
Okay.
Put it in cups so you can put it in a pot so you can make the cake.
Okay, good. Like in baking a cake. And what tool would a chef use to determine their fractions?
A measuring cup.
A measuring cup. Good. Another instance that we may see fractions every day is when we're working with tools. What are some tools in our classroom that we've used during math class that actually show fractions? Jalen?
The fraction strips.
The fraction strips. Good. That's an exact example. Nadia, what is another example where we may use fractions in our classroom?
When we're using rulers.
When we use a ruler. With math, I think it's very important to connect their skills to real life experiences and everyday real life activities that they may encounter, so that they know that this isn't something that they're just learning because it's in our book. It's a lifelong skill. All right, so the first way that we're going to talk about comparing fractions is by using visual models. And the visual model that we're going to use today, which is something new, is our big inch. And it's exactly what its name says it is. It's a big inch. This is like taking 2 little bitty inches from a ruler and blowing it up. And we're going to use this to compare fractions. I'm not going to tell you anything about what's inside this bag. I want you to open it up, explore, and talk with your partner about what each piece might represent.
Those are the 4s. How many? 1, 2, 3. How many is that? This, how many you got? 1, 2, 3, 4, 5, 6, 7. Then more. It's 8. It's 8. So these 8s. 1, 2, 3.
This one is
6, 7, 8, 10, 11, 12, 13, 14, 15, 16.
and this one and the yellows are 16.
You want to see if it makes 2 if we put the 2 over it? You see how it makes 2? Hold up, that's 2. Yes, it makes 2.
Okay, let's look at the big inch. We're going to use this instrument to compare fractions that don't have the same denominator, okay? Take out for me 1 green bar and put it in the hole. Put it at the very end where 0 would be. Very good. Only 1, only half, okay? Now, so what fraction does this green bar represent again, class? 1/2, okay? I want us to compare 1/2 to 2/8. Which color did you all tell me represented the 8s? Red. Take 2 of the 8s, and you're going to put the 2/8 on the stage behind the half. Only 2. How many 8s do you all have? Only 2. And they should be standing up, you guys. Like this, just like mine. 2 8s. Now, how does 1/2 compare to just 2 8s?
1/2 is greater than 2 8s.
1/2 is greater than 2. How do you know that, Kalia?
Because the 2 red bars are lesser than
Are less?
the green bars.
They're. How do you know they're less? What are you looking at? You're looking at its what?
Length.
So we said that 1/2 is greater than 2 8. So which fraction will the alligator class be eating? 1/2. The 1/2. So 1/2 is greater than 2 8s. Okay? So I'm going to give you some fractions, and you're going to use your visual model to compare. Are we ready?
Yes, ma'am.
All right. 3/4 compared to 7 8. 3/4 compared to 7 8. How does 3/4 compare to 7 8? So you have your 3/4.
I got this. Put yours in.
I want you to compare the 3/4 first. So the 3/4 is what? The way in which I've changed my teaching since Common Core was introduced is having the children to explain their thinking more. Especially in math, it's no longer just getting to that final answer, but it's taking the time to explain their steps and their actual thinking. How does 1/2 compare to 12/16?
It is less than.
How do you know?
Because there is more 12s. There's more 16ths than. There's more yellow ones than green.
What are you looking at? Are you looking at the number or
The number.
the length?
I said the number.
The number. So because we have this 12, you're telling me just because this has 12, it is longer? Remember, we talked about fractions. Fractions can be tricky because sometimes do we actually have to look at the size of the number? No. When we've done equivalent fractions in the past, we've seen instances where the fraction with the larger number may actually show a smaller amount. So when we compare using a visual model, are we looking at the numbers? No, because this is a ruler. What does a ruler measure? The length. So when you compare, you're actually comparing it not by the number, Tanya, but you're comparing it by the what? The length. And we can see that the length of 12/16 is longer than the length of the what?
1/2.
Of the 1/2. Of course, I started with the visual big inch, which was more concrete. They could visually see that it was longer. I went next to using the least common multiple because they had the background knowledge for completing that method. And Terrius, if I had 1/3 compared to, let's say, 2 8s, what could I do to actually compare them? Their denominators are not the same. What could I find?
Find the lowest common multiple.
Let's take the example 6 8s and 4/5. How does 6 8s compare to 4/5? Can we compare them as they are? No, we must make them have common denominators. In order to do that, we have to first find a multiple that they both share. Prior to today's lesson, the students learned to form equivalent fractions. They learned to form equivalent fractions by both multiplying the numerator and the denominator by any number, and also by dividing the numerator and the denominator by a common factor. We're going to compare our 8s to our multiples of 8 and our multiples of 5. Okay, now, what are your multiples of 8?
8, 16, 24, 32, 40, 48, 50.
All right, good. Very good. Typically, we would go through and list the multiples of 5, but can we tell which multiple is going to be the least common multiple without listing it? Sanaya, which multiple would that be?
40.
How do you know that 40 will be the least common multiple of 8 and of 5 without writing out your multiples? How do you know?
All the multiples of 5 are going to end in a 0 or a 5.
And what least common multiple did we find again?
40.
Now that means that we can go back to this prior knowledge we already have. If we change 6/8 to a fraction with 40 in the denominator and 4/5 to a fraction with 40 in the denominator, we can compare. Can we do that?
Yes.
Yes. Let me see you do that on your paper. One of the major shifts with Common Core in mathematics is focus. That means that we'll teach less, but the children will learn more. Okay, so this is the second method for comparing fractions. Are you all ready to do a couple of examples on your own?
Yes, ma'am.
All right, let's compare 1/7 to 1/2. Not only do I like the fact that we're narrowing down our topics, but also the fact that all states that have adopted the Common Core will be on a more level playing field. Some states, of course, in the past have had more rigorous standards than other states. So this puts us all on a level playing field, and all students will have the same opportunity to learn at the same levels. Are we ready for new knowledge now?
Yes.
Are you sure you're ready? Okay. So fractions can be compared using benchmarks. And a benchmark is a common number that can be compared to another number. 0, 1/2, and a whole 1 are going to be your benchmarks. What if I said to compare 3/8 to 5/6? We're not going to use a visual model. We're not going to use our least common multiple, but we're going to use benchmarks. We're going to use the benchmark half, okay? So first, let's take 3/8. Let's look at 3/8. If we're dealing with 8s, what would half, raise your hand, of 8 be? What would half of 8 be?
4.
4. So half of 8, Amaya, would be 4/8. So let me put that on my number line. So if I'm dealing with 8s, half would be 4/8. Now, look at 3/8. On this number line, would 3/8 be less than half or greater than half, class? Less than half. So if 3/8 is less than a half, but 5/6 is greater than a half, then what can we say about this equality? What can we say, Maraciana?
3/8 is less than 5/6.
3/8 is less than 5/6. Look, you were able to do that without using your visual model, without using your common multiple. You just solve this inequality simply by using your benchmarks. So the benchmark that we're going to keep in mind is a half. Are you all ready to try some examples? All right, good. Let's move on.
Okay. Half of 8 is 4/8, so we will name 4/8 4/8. I mean 1/2 4/8.
And then we will put
It'll be 4/8.
So we'll put 4/8 above 1/2.
Okay, so it's 4/8. Is 4/8 compared to 4/8 is equal to, so we put 4/8 right there.
4/8 greater than 4/8 or 4/8.
We'll go right up to,
Less than 4/8 or 4/8 equal to 4/8.
and then half of 12 is 6. So that would be 6/12. So we rename 1/2 6/12.
Actually, my favorite part of the lesson happened at dismissal. I had Lorenzo to tell me Miss Dennis, I don't want to go home. I want to go back upstairs and do more benchmark fractions. So that was nice. It's nice when the students are wanting to learn more.